Welcome, automotive enthusiasts. Today, we're delving into the engineering behind electric vehicle motors. Lamborghini has just announced a breakthrough in their hybrid drivetrain technology. Before we explore the latest advancements, let's clarify the fundamentals. Electric vehicles primarily use two types of motors, radial flux and axial flux. Historically, DC motors were common, but modern vehicles demand higher efficiency and performance. Modern electric vehicles predominantly utilize AC motors, specifically induction and permanent magnet synchronous types, due to their superior power density, efficiency, and precise control. The battery in an electric vehicle supplies direct current. To operate an AC motor, an inverter converts DC to the required alternating current waveform, eliminating the need for mechanical commutators or brushes. The traction motor, whether AC or DC, converts electrical energy into mechanical motion. In contemporary EVs, AC traction motors are preferred for their efficiency and smooth operation, enabled by advanced inverter technology. The new Lamborghini Temerario incorporates YASA's compact, high-performance, axial flux electric motors within its hybrid system. However, the significance extends beyond Lamborghini's innovation. It marks a pivotal shift in electric motor technology. This revolution in electric motor engineering is redefining performance standards for electric vehicles worldwide. For over 2 centuries, electric motors have been classified into two principal types, radial flux and axial flux. These represent two distinct methods of generating rotational force from electrical energy. The radial flux motor is the most prevalent design, found in applications from remote-controlled vehicles to modern electric cars. Its architecture features a cylindrical rotor surrounded by a stator with magnetic flux radiating outward from the center. The stator generates a magnetic field perpendicular to the axis of rotation, inducing torque on the rotor. This configuration is valued for its simplicity, reliability, and cost-effectiveness, making it the industry standard for decades. Its widespread adoption is due to ease of manufacturing and proven operational stability. In 1821, Michael Faraday introduced the axial flux motor, a fundamentally different approach to electromagnetic rotation. The axial flux motor, sometimes called a disc motor, arranges the stator and rotor as parallel discs with magnetic flux flowing along the axis. This design maximizes the active surface area for electromagnetic interaction, resulting in higher torque density for a given volume. The axial orientation of the magnetic field enables efficient current flow and improved thermal management. This configuration allows for greater torque output and more effective cooling, as heat-generating components are closer to the surface. The result is a motor capable of sustained high performance with reduced thermal limitations compared to traditional designs. Axial flux motors can be integrated in locations unsuitable for radial flux designs, such as between an engine and gearbox or within wheel hubs. For nearly 2 centuries, large-scale production of axial flux motors was hindered by manufacturing challenges. Tim Woolmer, a British engineer, revolutionized the field by redesigning the stator and optimizing the winding configuration. By eliminating the iron yoke and refining the copper windings, he achieved significant reductions in weight and improvements in efficiency. He also developed advanced oil cooling techniques to further enhance thermal performance. This innovation led to the founding of YASA, specializing in yokeless and segmented armature axial flux motors. While the name may sound complex, the underlying engineering is a leap forward in electric motor technology. Today, YASA's axial flux motors are approximately 1/4 the size of conventional radial flux motors used in electric vehicles. They weigh about half as much and deliver twice the torque output. Their compactness and power density have attracted leading automotive manufacturers such as Ferrari, Koenigsegg, and now Lamborghini, all integrating axial flux motors into their high-performance vehicles. Mercedes-Benz recognized the potential and acquired the entire company. Consider a 225 kilowatt axial flux motor weighing only 7 kilograms. This is lighter than many conventional brake discs. Such motors can be installed directly within the wheel assembly, as demonstrated in the Mercedes Vision 111 concept. This eliminates the need for traditional drive shafts and, in some cases, gearboxes. The resulting weight reduction enhances handling characteristics, improves acceleration, and increases driving range. Radial flux motors remain relevant with ongoing advancements in power output and efficiency. Companies like Rimac and Lucid are extracting remarkable performance from state-of-the-art radial flux motors. Aston Martin has even partnered with Lucid to access their advanced motor technology. The next frontier for axial flux motors is aerospace, where their high power-to-weight ratio is transformative. Evolito, a spin-off from YASA, is developing electric flight solutions with motors achieving up to 50 kilowatts per kilogram. This technology brings the concept of practical electric vertical takeoff and landing vehicles closer to reality. The next time you encounter an electric hypercar or an advanced air taxi, consider the engineering behind its motor technology. Performance is not solely determined by batteries or software. The true innovation may reside in the motor itself, whether radial flux or axial flux, quietly delivering power and efficiency. Subscribe for more in-depth explorations of automotive engineering and electric vehicle technology. Thank you for watching.